Hello, everyone. This is Todd Kelly with StepCG, and we're here to talk today with a couple individuals from StepCG that are been very experienced in the area of Wi-Fi and cellular technologies, 5G, 4G networks, and try to help clarify some of the differences between these technologies and how to use them in different use cases, or when to think about using them in different use cases, because it's kind of an emerging area. Wi-Fi 6 is just coming out into the market and being used in enterprise networks, and 5G is kind of out there and starting to be used in more of an enterprise context, except for your phone. So we thought it'd be appropriate to kind of dive into this in a more dynamic fashion, have a conversation, bring you into our environment here in Covington, Kentucky. We're in our innovation center, got an 8,000 square foot space with a bourbon bar and actually a brewery, little tap brewery on the other side of this wall. And right now we're sitting in our lab environment here. If you're ever in the area and want to stop by, just reach out to us. It's a really nice environment. We can show you a lot of the technologies we're talking about here today. I've been at StepCG for since March. A lot of my background has been in cellular technologies and networking. Spent 10 years at a company called Cradlepoint, which is around the cellular edge, using cellular technology for business applications for IoT, mobile networks, and branch networks over the years. And prior to that, spent most of my career building out the carrier infrastructure and designing that with the carriers for supporting wireless data over those cellular technologies, 3G, 4G, and the emerging 5G here we're going to talk about today. StepCG focuses in helping our customers adopt and build cutting edge networks that are easy to operate, and for both wired and wireless infrastructure on the LAN side, connecting all different use cases, IoT and compute, and also on the WAN side and different technologies, including wired and wireless technologies such as cellular. We've had a lot of experience. We have about 9 certified experts in cellular technology with some of the vendors on the cellular side, and we have about just as many experts certified on the wireless side and networking side. So we thought we'd open up our environment and make this dynamic. As some logistics on this webinar, on the right side, there's some Q&A. Feel free to keep popping in questions. I'll be monitoring those and as we go along here, and we'll answer them as we go, as we have this conversation, and hopefully give you a little bit more clarity about the use cases of 5G cellular versus Wi-Fi 6 technology and what use cases to use. Before we do that, though, I thought it'd be good, let's have maybe Ben Fisher introduce himself and Nelson Carrick a little bit about themselves, so you know who's talking here, and we'll get this conversation going. What do you think?
Absolutely. Thanks, Todd. So like Todd was saying, I'm Ben Fisher. I'm one of the solution architects here at StepCG. I've been on the team since the beginning of the year. Prior to that, I spent about 8 years with the Indiana Department of Transportation, kind of going through various stages there, finishing out as the head architect for their intelligent transportation systems. So a lot of IoT, a lot of cellular, wired, fiber networks. So really excited to be here and just talk about the different use cases for 5G versus Wi-Fi 6 and kind of pull back the curtain a little bit and make it a little bit easier to digest. So please feel free, if you have any questions, throw them in the chat. Nelson?
Thanks, Ben. So like Ben said, my name is Nelson Carrick. I've been with STEP for about 5 years now, so kind of one of the early riders. Prior to that, I came out of the public sector, out of the education sector. So I spent a few years working in different school districts. So decided to join the private sector and kind of grow my knowledge and things there. So I've really focused more on the Wi-Fi side, more than cellular. So I am our CWNE, or Certified Wireless Network Expert. And that's really been my passion for the last few years, has really been designing wireless networks and getting those right. And for you guys that don't know, I think that probably one of the densest environments that we see wireless used in has got to be in the K-12 market. Just the sheer number of devices that they see brought in, as well as devices migrating. So they sit down for 90 minutes at a time and then they get up and they move to the next class. So it makes an interesting environment to try to design for.
That's great. Thanks, Nelson. And, I guess that is the other context of this conversation. We are kind of in the middle of the manufacturers and all the technology. So everything you read on the web about what the technology can do, we're kind of in the middle between you, the customers, and the manufacturers. So we're going to try to give more pragmatic view. It is a little early in some of these technologies about what we're seeing, and it may conflict a little with some of the marketing that you see from the manufacturers. But here at STEP, we like to engineer in excellence, and until we can actually see it ourselves and prove it ourselves, we usually are not committed to a lot of that, let's say, religion around what the technology can do until we actually can see it work in a practical environment. And I guess that kind of maybe starting with Wi-Fi 6, because it seems to be really one that has actually products on the market. Matter of fact, we have one here and a few others, and all in this lab that supports Wi-Fi 6. And I think a lot of people, a lot of our customers, especially in education, I think Nelson, maybe for you, is what is Wi-Fi 6? A lot of the K through 12 market and universities have Wi-Fi today. What is the thing that they should be looking at as far as technology and functionality that brings that they don't have today with their existing Wi-Fi networks?
Yeah, so there's a lot of different things that really changed with Wi-Fi 6. If you look at the older Wi-Fi generations, as those came out, they always focused, as those released, on more and more throughput. So it's always about, let's make it faster. So if you go back and look, you can see the data rates just climb with every generation of Wi-Fi. And with Wi-Fi 6, yes, they did increase throughput again, but the overarching goal was actually efficiency. So they wanted to make the network more efficient. And that really becomes because when you're doing anything wireless, it's a shared medium. So only one person essentially can talk at a time. They wanted to try to eliminate that. So they've actually borrowed from the cellular side. Cellular technologies for years have been utilizing something called multiple access, where they actually carve up smaller pieces of bandwidth and allow multiple devices to talk at once. So they wanted to bring that to Wi-Fi, and that's essentially what they did. So we're carving up that larger chunk of bandwidth that each AP is using, allowing multiple devices to communicate at once. And it also brings in sort of a management kind of platform, not to the level of what cellular technology has, but it does give a speaker, somebody in charge of the medium to kind of take control. So those are the primary goals of what Wi-Fi 6 was intended to do.
And within education, that's kind of a fixed building environment, and you can see kids have 3 to 5 different devices maybe using Wi-Fi as they walk into the environment, including the school network, and video is becoming more and more prevalent, even within the learning environment and outside the learning environment. But I guess Wi-Fi 6 with this efficiency, it brings more bandwidth and allows a lot more of these devices to be on the network at the same time.
Yeah, that's kind of the idea, is to allow more clients to connect and more efficiently transfer data. I guess the way I like to think about it is if you're in an auditorium and you have a speaker up on stage, every time that somebody in the room wanted to say something to somebody else, they would have to wait for the speaker to get off the stage. They would go up on stage and say what they had. But with Wi-Fi 6, it's more micro conversations going on in the room instead of having just a dedicated speaker all the time. So.
Gotcha. And maybe we'll double click a little bit more on that, to borrow a term from a Todd programmer, a former colleague, that he always used the double click thing, and maybe pivot over to 5G to get deeper on Wi-Fi 6. But similarly, Ben, on 5G, that's kind of, we hear this 5G buzz. 5G's kind of launched. What is 5G compared to 4G, and where is it in the context of businesses actually being able to use it besides cellular phones, really in communication? So more from a business context.
Well, I think the most important thing is we have an extra G in there now. But from a business perspective, it's really about doing something that Wi-Fi has done for years, and it's adding speed. And so migrating away from just focusing on the low and mid-band technologies and utilizing more of the high band, so the higher range frequencies, kind of 26 plus gigahertz range, where we can put a lot of information on the air. And so, with those kind of tighter waves between, and we're able to do more modulation and put more information out there, what we're really achieving is higher total throughput on the wireless WAN. And so from an organizational perspective, it's being able to get day zero, day one connectivity, having failover connectivity that's just as fast as what we have over the traditional wired services. And in some instances, as we start seeing gigabit plus LTE technologies, really it's going to enable businesses to continue to cut the cord altogether and go to a full mobile first solution. And I think as this year has really effectively demonstrated, the work all-wear kind of mentality and mindset is really important to just be able to pick up, go, and have that full business continuity without having to worry about 90 plus day trenching on fiber, getting those lease lines, having our MPLS circuits, having all that complexity there. What 5G is really helping to drive forward is having that instant access, high speed throughput, having equal prioritization and speed and dependability.
And so it sounds like Wi-Fi 6 and 5G are very similar in the fact that they're getting more bandwidth, more efficiency. Some Wi-Fi is kind of using some of the technology from the cellular world. I guess for the audience and for businesses, when they think about, okay, now you got similar technologies, what are some of the use cases that are more appropriate really for a business to consider for 5G that 5G is optimized for? Because 5G can maybe do a lot of things because that Wi-Fi can, and Wi-Fi seems to be able to do a lot of things 5G can. So how does an IT person, at a government or a state, local government or education or a healthcare organization, as they look at this technology, how should they think about when to use or consider the 5G technology versus Wi-Fi?
Yeah, I think that's a really great point, right? And, part of it has to do with how we're getting to the speeds. So those high band frequencies, they don't really penetrate walls and windows very well. That's part of the reason why as we go into most any metropolitan area, we see towers popping up everywhere. We can't cover these large swaths of land just because, from a physics perspective, the way it gets absorbed and the signal dies down as it hits and it's absorbed, it really doesn't work as well once you're inside the building. So that's a big reason why we see so many more outdoor mounted antennas to access that 5G connectivity. So while there is some advantages to it from your backhaul perspective, as far as client density and once you're inside, we still need to take that LTE signal and convert it over to traditional Wi-Fi, just because one, the amount of time and the cost difference to put LTE chips in every end device versus a Wi-Fi chip that's already there. That's a pretty significant cost, and there's refresh cycles we have to consider with it. And then two, it's just client density, right? If we try to put every single internet connected device straight on the LTE network, it's going to overload it, it's going to oversaturate it. So we rely on things like our traditional routers doing NAT and PAT to help distribute that load and not have to put everything right onto the cellular radio access network.
Gotcha. So it sounds like it's an alternative as a WAN interface versus a wired WAN from a cable modem. And so what kind of speeds does 5G and latency does 5G provide maybe in that use case as a potential WAN for a business versus calling up your cable company or dealing with a bunch of broadband providers across the country? It sounds like you can use 5G and maybe even 4G. What kind of speeds for 5G are they expecting?
Yeah, absolutely. So, it's kind of two things, right? So most of the carriers today are saying that they have their 5G networks. And it's a little smoke and mirrors, like as we transition from 3G, 4G networks to long-term evolution networks, where it was really kind of the same thing, just by a different name. And so what we're seeing as the first wave of 5G is kind of that mid and low band 5G, where really we're just realizing what LTE, the more recent releases of the standards around that are able to do. So upwards of 150 plus megabits per second. Now, as we transition into what I'll call true 5G and the next generation of devices, is where we're going to start to see gigabit plus throughput. And so we're going to see that real alternative to fiber to the prem, last mile deployments. And so really driving that work all-where mindset and just instant pop-up, same as what we have with the wired connectivity. But today, with what we have and the devices that are out there, the backhaul network that the carriers are using has been upgraded enough to a point where they're really unleashing the throttle that they've had on the LTE 4G networks for years and allowing us to really use the full potential of 4G LTE. And the other part that's really exciting of that 5G is bringing to us is because there are so many more towers being installed. There's a lot more fiber being installed on that kind of middle mile. So we're getting the latencies down because we're not having to travel several miles over the air back to the tower to finally hit that fiber transfer point. We're hitting it in our local neighborhoods now. So the latency is driving way down into the 10, 20 milliseconds as opposed to having traditionally been 60 plus milliseconds. So for our folks, especially in government, and as they look towards smart cities, connected, safe cities, what they're going to see is that they can get even more real-time CCTV systems. V2X infrastructure, is going to be able to have those near real-time communications. So we're going to see the adoption and the evolution of the autonomous self-driving vehicle even faster as these technologies roll out.
And so it sounds like in the 5G area, according to theory, actually, if we, I think we all saw this, and some people in the call may not know. I think the first, I've been paying attention to Telstra in Australia. I think they were the first to kind of launch a very broad countrywide service for business, leveraging 5G technology. And I think you were talking about different bands. There's bands of frequencies in the lower band, which is under 2 gigahertz. And then mid-band, I think we were talking about, which is up to 6 gigahertz, and then this really high band above 26 gigahertz called millimeter wave. All those technologies can be used for 5G, I think is what you were saying.
Right.
What's kind of been deployed is the middle band and low bands, and then the high bands, because of the physics involved, they're being deployed very tactically in metropolitan areas to get really high, super high bandwidth. But in all cases, because of the fiber footprint, all these different bands, no matter what you're doing, can lower the latency. Sounds like the throughput is getting towards more of the gigabit speed. But I saw, like with Telstra, some of the business users are getting hundreds of megabits, close 700 to 800 megabits, in the system. And obviously, as it loads, it will probably change. So definitely different than what we're seeing today on 4G gigabit LTE, which is sometimes 20 to 30 on average downloads, maybe higher, depending on some of the technology. So sounds like for a primary WAN, low latency, really high bandwidth, they can replace a WAN circuit for a lot of businesses is a good one, or be a really reliable backup for a wired infrastructure as a wireless WAN to back that up. And also it sounds like, as you were talking, a mobile network, so vehicles and tracking vehicles and using it as a broadband mobile network. So Nelson, I guess on the Wi-Fi 6 side, a lot of similarities, but I guess for the audience, clarifying, we had a couple of use cases here for the cellular of where it's really good for. Where do you see the Wi-Fi 6 use cases for maybe even education, government, or healthcare organization? Where do you see the benefit of that?
So it's definitely a different use case. Like Ben was saying, with some of the 5G technologies, especially the very high band tech is not built to be able to go through walls and things. So that's where Wi-Fi really starts to fill that gap, is to be able to cover indoor areas, things that you're not going to see, 5G millimeter wave stuff be able to do. So I think that's probably your most common scenario, and where everybody's used to seeing Wi-Fi is definitely indoors. That's not to say that there's not a place for Wi-Fi outside, but for the most part, it's going to be your indoor coverage, and it's going to be something where you have more control. Because an important part to remember, the difference between Wi-Fi and pretty much any cellular technology is licensed versus unlicensed spectrum. So Wi-Fi operates on an unlicensed spectrum, which basically means, if you can go buy an access point, they generally operate on 2.4 gigahertz or 5 gigahertz radios, and you can put that AP anywhere you want, with few exceptions, and you're kind of in control of that. It's up to you. With the cellular technologies, those all operate in licensed spectrum, so you actually have to cooperate within FCC guidelines and make sure that you're being legal on how those are deployed. So most of those are operated generally by bigger carriers rather than individuals. So I think that's most likely where we'll see the biggest differences. If 5G can't make it to where you're needing it, then you have the control with Wi-Fi to bring that where you need it. So.
What kind of speeds, for Wi-Fi 6, like what kind of technical benefits and, performance and do you kind of see as an advantage over the existing Wi-Fi standard of 8
So there are a multitude of things to think about when it comes to speed on Wi-Fi. To probably make a few manufacturers upset, a lot of them really like to advertise the Wi-Fi 6 maximum speed of 9.6 gigabits per second, which is theoretically possible. But what that requires is a massive use of channel allocation. So you end up losing the ability to have multiple APs beside each other talking simultaneously on different channels because you're going to use so much of your spectrum on one AP. And then there's also this concept of spatial streams. So a single device could talk to a single access point on multiple spatial streams. And in order to get to that 9.6 gigabits per second, you have to have 8 spatial streams. And that's something that's not really seen. There's not many APs that I've seen that are 8 radio APs or have 8 antenna elements that can handle 8 spatial streams. So I don't think you're going to really see that all that much. Where the speed improvements are really going to come from is really in the modulation, so they can encode data more efficiently on the medium and just transfer more data. I think it's more realistic to expect speeds around the 500 megs per second speed on your average kind of device, but it all depends on density as well. As you get more clients into an environment, they're sharing the same airtime, so the more you have, the slower each gets respectively.
Gotcha. And I guess you talk about licensed and unlicensed. When I think about licensed spectrum and LTE technology, there's a lot of security that's been there. The federal government uses it to communicate. We've all used it to communicate. And then unlicensed spectrum seems to be something that might be less secure, at least a perception. So is there any other additional security in Wi-Fi 6 when communicating over this unlicensed spectrum using Wi-Fi, a standard, that makes it, that helps it protect, from eavesdropping and man in the middle and you're, compromising the integrity or confidentiality of your data?
Yeah. So not necessarily related to Wi-Fi 6, but there have been some improvements upon just wireless security in general. So a few years ago, we got hit with the WPA2 crack that came out. That was a key reinstallation attack that allowed somebody to essentially force a man-in-the-middle attack and start decrypting your wireless transmissions. So WPA3 seemed to hold up well against that. We haven't seen that get broken yet. But probably the biggest part of WPA3 that hasn't been widely adopted yet is something called opportunistic wireless encryption, commonly also just referred to as open wireless encryption. So if you connect to an open network, a set of keys essentially are generated on the fly between the access point and the device to be able to secure that communication versus just allowing it to go unencrypted in the air. So.
Gotcha. So like when you're in an airport or when you're on guest Wi-Fi, that connection before you even log in would be encrypted, that nobody can eavesdrop in, and kind of helps make that experience a lot more secure.
Yeah, absolutely.
So I guess some of the why is some of the so with security, I guess Wi-Fi 6 and 5G, obviously in adopting these different technologies, we talked about the performances, density. How mature do you, I guess, staying on Wi-Fi 6 for a moment, how mature is Wi-Fi 6 for enterprises to adopt? Is this something that, enterprises just start planning for and engineering and planning an upgrade for sooner versus later? Or what's your kind of viewpoint on that, Nelson?
Yeah, I mean, I think it's always important to be kind of planning and designing for it. If for nothing else, when you go to buy more wireless access points at this point, that's what's on the shelf. That's what manufacturers are selling. So that's what you're going to be buying. So you might as well go ahead and be planning for it today. In terms of experiencing all the benefits of what Wi-Fi 6 really brings to the table, that becomes a little bit more of an interesting conversation. You know, Wi-Fi has always run on 2.4 or 5 gigahertz bands, and Wi-Fi 6 is really no different. It does that as well, which means that we're sharing Wi-Fi 6 in the same space that we had Wi-Fi 5 and 4 and the legacy stuff before that. And a lot of the benefits really require kind of a clean environment. As those legacy devices remain on the network, they're going to bring down some of the functionality. But it's always important to be kind of planning forward and trying to migrate toward the newer technologies.
Is there any hidden costs on the back end? Do they need new cabling for their types of cables they use for the access points? And I guess the second question is, with Wi-Fi 6, do they need less access points or more or the same?
I mean, that's kind of a difficult question to answer. It always depends on, your unique scenario, how dense your environment is, what your environment looks like, things like that. But in terms of the cabling, they are recommending that you go with Cat 6A because it is a thicker gauge cable. It's able to carry power more efficiently and carry more power because as we move forward, access points are more than likely going to go from being 2 radios to 3, 4, potentially more radios on them to be able to have additional clients connected on separate spectrum to be able to talk even more clients simultaneously. And when we add more radios, that does take more power. So that's the primary reason. So you'll see a lot of manufacturers pushing, the multi-gig ports, which we're not at a point where we can really say if we're going to need multi-gig, but it is something to definitely consider, especially as we see these multi-radio APs come out. But definitely on the PoE side, we want to be running thicker gauge cable.
Yeah, well, that's interesting. I mean, as the enterprise starts planning for this, it obviously depends. Sounds like the same number of access points would still be needed because the same power output and frequencies are being used. They're just being used more intelligently to connect more devices, provide more speeds and use of that spectrum with additional security. And then the only kind of physical things to consider when migrating to Wi-Fi 6 is possibly using Cat 6A cabling if you don't have it.
Yeah.
If I was summarize that maybe correctly, I hope.
Yeah, I mean, it's always worth looking at your environment. Like changes do happen, right? But for the most part, you're designing very similar to what you did for Wi-Fi 5. So I'm never one that will say that you can just take access points and one-for-one replace them. But it'll be pretty close to that for the most part. So.
And Wi-Fi kind of feel like is an extension of your own private network that you're allowing connectivity and also maybe allowing some guest access to. And the cellular world, you pointed out, and I'll shift over to 5G. In the cellular world, you kind of are trusting the operator with your network, and you can run your own VPNs over it. But there is this concept of private networks in cellular that cover broader areas, campus areas, manufacturing, ports, airports. And you always have this option of private networks with the carriers. And maybe for our customers and attendees on this webinar, we talk about, like, Ben, maybe a little bit about 4G and even 5G networks and the couple private options they kind of have. to allow them to extend their own network over cellular, and some emerging trends you see kind of going on there.
Yeah, absolutely. I mean, I think, the most important thing that I've noticed is when we look at private cellular networks, the same security that we get with our phones today, right? Having to have the SIM card in there to gain access to the network and marrying our IMEI with our ICCID and saying that, yes, this device is trusted. That translates down to the local network as well when we're talking private networks, be it a private access point network or APN from one of the large carriers, or even deploying your own LTE infrastructure, either outright purchasing it and acquiring spectrum like the CBRS band 48, or partnering with.
Can I interrupt you there? You talked about two options: securing your own APN. For the customers, what does that mean? Sounds like that's the first option. Can you explain a little bit more about that?
Yeah, so securing your own APN and private APN networking is typically what a network operator will start to do as they enter the foray into having their own private LTE network. So rather than having to manage all of the eNode Bs, or as we equate to Wi-Fi, the equivalent of an access point, and all of that back-end infrastructure associated with it, you can let the carrier maintain and manage it, and they essentially give you your own private slice of their network. And what we end up doing is establishing a VPN between your local network, usually some kind of redundancy between your data centers or your operational locations, back to carrier data centers, so that instead of having to have hundreds of thousands of IPsec VPNs for all of our operational technologies, we're only managing essentially 4 VPNs to the carrier's head ends, and then bringing all that data back across the internet encrypted already, reducing some of the hardware footprint that we need to maintain that robust security presence, while also treating the carrier's network as if it's an extension of our own network.
Gotcha. So you're trusting the carrier to securely transport all that connectivity from your IoT or SCADA or cameras or mobile vehicles or even phones and tablets over their network securely to come in over dedicated links into your own data center. But you still are trusting a carrier to do that. You have to select a carrier or multiple carriers to build that out. So that's the first option. So thank you for explaining that. And then I think we were starting to talk about something called CBRS or another alternative that's starting.
Yeah, so the other alternative, and why I've seen this really take off in the last year, is to Nelson's point earlier about how traditionally Wi-Fi operates in unlicensed spectrum, and LTE on the inverse is licensed spectrum. What happened in the last year is the FCC took this band of about 150 megahertz and said that we're going to allow this to be operated in a lightly licensed manner. So now organizations and individuals can put up the same infrastructure that our traditional telco carriers do, and they can get access to spectrum without having to go out and purchase 5 to 80 megahertz of spectrum, spend hundreds of thousands of dollars on licensing with the FCC, getting specialized equipment. They can utilize this band, or the alternative, they can also partner with a carrier again, have that carrier install their equipment locally and utilize those carrier bands. So again, going back to those low, mid, and really high millimeter wave bands, they can put that carrier infrastructure in, but instead of going over the internet and going over the carrier's network, essentially that radio access network, or RAN, that our devices connect to ends up dropping off locally straight to your network without having to go through their kind of backhaul infrastructure. What you're really doing is leveraging their licensing and their ability to manage and service it. Or if you do go the CBRS route, you can either manage it yourself or work with an integrator to help you manage, run, and maintain that carrier grade network on your own local infrastructure.
Gotcha. And the concept of private wireless networks besides Wi-Fi has been there for a while. Right. But it sounds like this is something the industry has adopted that actually allows the same manufacturers of these devices just to support a different band. So you don't have to custom make a device to work on those other private technologies that have been around for a while. Now this allows economies of scale to leverage some of the same devices for businesses to adopt using these private networks and spectrum I guess, CBRS spectrum that's out there. And then how they communicate over it, I think some people get confused. That's a private network using CBRS spectrum. But is that 4G or is that 5G, or can it be 5G or 4G? So I think, can you clarify on, you've kind of talked about the layers of frequencies that can be used, unlicensed, leveraging some of the cellular technology, but is it 4G or is it 5G or is it both? How do you clarify that?
Yeah, I think that's a really confusing part, right? Especially as, we hear, oh, we went from 3G to LTE to 4G, 5G, and how all this works. And we have all these different ranges of frequencies. And is this one just 3G? Was this 4G? Is this 5G? What's really been going on is there's this overarching body of standards, much like 802.11 is for Wi-Fi. There's this working group known as the 3GPP that does all of the standards for LTE networks. And so just as we have Wi-Fi networks that use 2.45 and in the future 6 gigahertz, LTE networks can also operate on all these different bands, but being within one generation. So the big changes that we get here, 4G to 5G, isn't necessarily the adoption of these new high frequency bands and the changes that come with that. It's a change in modulation, so how densely we can put information on the air. And then also one of the other big things that's coming from 5G versus 4G LTE is we're starting to finally deprecate the support for GSM, CBWMA networks. We're not having to be backwards legacy compatible anymore. We're looking more towards the future and saying, yes, we've sunsetted those devices. Everybody's handsets support the newer technologies. We don't have to worry about that coordination. We can start looking towards the future. So it's that abandoning of legacy stuff that had kind of been holding us back, and moving forward while also utilizing all these ranges and everything else that comes from that, and then adopting new modulation to get the higher speeds from the next generation of technologies.
Yeah, interesting. So the radio environment's just adopting to modulate and get more bandwidth and lower latency. And then the network infrastructure is also being changed behind the scenes on the transport side. But there's also in the standards defining way how they do that is bringing compute closer to the edge. I think it's mobile edge computing. Mm-hmm. So for a business that's looking to adopt a private network, as a 5G network is deployed, the carriers sound like they're setting up infrastructure that you may be able to leverage for your business, put your data, even allow closer access to your data and compute. As you use the networks, it'll be more tied into data processing and being able to be a part of your business, an extension of your business, versus you having to build out all your infrastructure at every edge of your network, which sounds interesting. I think the terms are also network slicing versus with software, so everybody has their own slice if you use the operator network versus just an APN and building that out a little bit more physically than automated. So I guess if we were to bring it back up, is there questions? I think there's a couple questions coming in. One is, are there devices coming out that work on Wi-Fi and 5G and will seamlessly switch between them, perhaps when going outdoors to indoor Wi-Fi? So do you guys want to comment on the roaming aspects of Wi-Fi with cellular technology, with cellular devices?
Yeah, I'll take that one. So there absolutely are devices that support both 5G and Wi-Fi and Wi-Fi 6 and are going to be able to do that seamless roaming as we hand off between them. And one of the big things that plays into how we do seamless roaming has to do with where our sessions are maintained. And so as we think of the network stack, it's traditionally a layer 4 thing where our session is maintained. And that just has to do with the ports and the IP address of where your authentication has happened and where that data stream is going. And so as we think towards more private networks, and especially with things like private 5G networks, private LTE networks, private APNs, we can have our session be advertised from the same data center as our traditional network is. And so that as we roam off of our campus network and onto the macro network, that session doesn't have to be reestablished. So you see that seamless roam. So the ability is there, and there's devices. I mean, we can do it with iPhones, we can do it with cradle point routers, laptops, and so forth. It really just comes down to a network design and implementation aspect, as well as what kind of session reestablishment is within our business applications.
Gotcha. Yeah, and I see this like in the public safety with police and emergency vehicles. They even today they have this capability, but they require a software that runs on top of the network that establishes its own persistence IP connection. So as you switch between them, it sounds like now there's also this ability to start to not need that software, according to this question, seamlessly switch, leveraging you know, Wi-Fi roaming, if you will. And I think one of the carriers, T-Mobile, I think, also offers this today, doing Wi-Fi calling at home and seamlessly switching between that and the cellular network to get more efficient communications on their network. I think there's another, what are 2 to 3 benefits and risks of adopting 5G and Wi-Fi 6 for a healthcare organization? I guess for 5G, I can maybe take that for a healthcare organization, more for what we've personally been experienced in the past for 4G, but definitely can help with 5G is really adopting 5G for ambulatory and first responders as they come to service a victim that need immediately getting that communication back to the hospital. Today they do that with cellular with a lot of information from the 12 leads that they put on this patient, but now they can start to adopt video and virtual reality. And so as they're coming in and as they're treating a patient in need on their way to the hospital, there could be real-time communication with an expert and with a video assessment of an individual. And 5G will enable that with the capacity that it has on the network for higher bandwidth and versus just telematic data that they get today. So I think that's definitely one where you could look at 5G really enabling healthcare. The second one for healthcare and 5G that we've seen as a 4G use case is really just doing pop-up clinics, mobile clinics, or mobile testing centers, and being very mobile, being able to put up broadband, to be able to do x-rays, to be able to do very high bandwidth applications, and have a virtual SME because the healthcare organizations are trying to bring more and more healthcare closer to the communities, to where people need it. That's why you see it like CBRS and Walgreens and of the world, and Rite Aids. You can go in and see a doctor. Now you can actually, one doctor can be centrally located and serving all these and have a video assessment as they actually tell them to use different things and interact in real time. And so I think 5G is going to really transform healthcare and executing on that vision and bring it closer to us and leveraging for some of these enhanced remote subject matter expert use cases and augmented reality, I think. How about for Wi-Fi 6, Nelson?
Yeah, I mean, I think the risk is probably pretty similar. Just deploying Wi-Fi 6 itself doesn't necessarily inherently offer any additional risk, but the enablement of what that does for how it can be used is probably more the risk factor. As we move towards seeing more and more adoption of AI and machine learning and things, and just different types of applications that we haven't seen before, I think that opens us up to risks that we're just not used to seeing just yet. So.
Yeah, and I guess the risk on 5G is you start to become dependent. I didn't touch on that. In those use cases, I think the risk is it not being there. The technology and coverage. So if you depend on it, it might not be as. I think it's going to require a lot more, trial and proof of concept in your specific environment, and using your specific applications to make sure it actually will work as advertised, and as the industry evolves there. But I think it actually it protects against a lot of risk that's there today, because a lot of remote healthcare clinics don't have this capability, and 5G is a path diverse connection. In other words, if a tower goes down, it automatically is connecting to multiple towers. So the whole tower backhaul gets taken. It's actually self-healing. It'll go to another tower it can see in a metro area. So, so if you have wire connections, there's lots of points where these all come together. It can take down all your wire and redundant connections on wired WAN. Cellular actually, you can fail over to it, even if it has a failure there, it kind of mitigates a lot more risks than that you have. So I don't know what you think, Ben.
Yeah, I think, that's absolutely true. And the other thing, right, is because of the way LTE does backwards compatibility still, and even though I talked about how 5G is abandoning some of the GSM type networks, we're still going to have support for our 3G, 4G networks as well. So we can fail back to those other technologies, and also utilizing those lower bands at lower speeds where we can have a tower farther away to do that kind of fallback. But another interesting benefit that I think is kind of worth talking about, both with any type of cellular communication and Wi-Fi, especially in healthcare, is, as we talk about these private cellular networks, the healthcare organizations can see some real benefits of moving all of their operational technologies onto that private cellular network and leveraging that SIM card based authentication, not having to worry if the device has drivers for the Wi-Fi support and trying to do those kind of media conversions, or hoping that their Ethernet handoff and as they look towards trying to be agile and redeploy the floor and get equipment where they need it if they don't have that traditional wired infrastructure, we can use devices that take the LTE media and pump it out as more traditional gig-based Ethernet and do that handoff. And those media converters tend to be more reliable than Wi-Fi to Ethernet converters have been in the past. We're not worried about trying to make sure that our .1x certificate-based authentication is there, making sure that we're able to rotate through WPA passkeys and so forth. There's a lot of that kind of gets forgotten about and doesn't get rotated through, and it leads to security breaches. But the other part of why we want to keep the Wi-Fi around is for the patients, so that they can walk into the healthcare provider network, hop on that, be fully segmented away already from those operational technologies. So if they are malicious for whatever reason, they don't have that insight into the operational network, but they do still have an easy access captive portal. They tend to have newer devices that work with all the different Wi-Fi standards. You can join through those without having to worry about how am I striking that right balance of security and operational security and protecting that core infrastructure, while also making it easy and accessible for the end user just by splitting them out completely.
Yeah, that's kind of interesting, because we were talking about Wi-Fi being in the building, cellular kind of for outside, and now you kind of talk about a healthcare or hospital where here's how you can use both technologies in 5G or 4G, I guess, but leveraging a private version of that, leveraging different spectrum. It sounds like the CBRS spectrum, which is 3.55 gigahertz to 3.7, and then you have Wi-Fi in this unlicensed spectrum of 2.4 and 5. So for Wi-Fi, it's there today, using it for operational technology and a lot of other front-end applications for patients and other applications. Now you can take your critical systems to scale the hospital to do more and have more bandwidth. You can take and segment your operational technology into this private LTE space away from Wi-Fi, take advantage of some of the security and make it more operationally easier to manage and secured, and then free up a lot of that other unlicensed spectrum for Wi-Fi to connect a lot more of the devices we see coming into the environment, support more technology to actually leverage Wi-Fi 6 advantages of bandwidth and connecting more devices, and get more secure and operationally manage it more efficiently. So I think we see that also maybe a couple of use cases at universities inside. They're trying to use Wi-Fi for connecting all their IoT and building management and surveillance systems. They're starting to take that approach because the unlicensed spectrum just isn't scaling. So, you only can put in so many APs to handle that. So this is a way to kind of take it, put it in a different spectrum that's unlicensed, and scale as we bring more devices, they're more demanding on bandwidth and performance. So that was a good question, I think, summary of closing on how to use both technologies in the same environment for the same kind of use case, as well as talk about some of the other use cases, of where they kind of shine. I guess in closing, let's talk about pricing and maybe what the economics are for an organization. Is Wi-Fi 6? Let's start there. Is Wi-Fi 6? We see that is that going to be more economical for a business to use, or is it going to be more expensive or lower? What kind of economics can a customer?
Yeah, I think that really depends on what the use case is. So if we were to look at a use case like, for instance, like IoT, Wi-Fi can be very good for IoT depending on exactly how much area do you need to cover and how many devices do you need to connect. So if we're looking at an indoor application, very few devices, but in a small area, then Wi-Fi is most likely the right solution, and it's going to by far be cheaper than doing a private cellular network, or even going out and doing like a private APN on a public network. But if we looking at an oil refinery that has IoT devices scattered amongst the entire facility, trying to blanket something like that with Wi-Fi is super expensive, because we're going to need to pull fiber or copper to as many places as we can to get multiple access points in, where a public network may already have coverage. So a private APN could give us that backhaul that we need. Or if we deploy a private cellular network, that as a lot fewer cells can cover the same kind of area. So it could kind of go back and forth just depending on the scenario.
Yeah, and I guess, Ben, on the 5G front, kind of 4G, 5G front, I guess, there's definitely the use of the public networks from the operators, either with private APNs or the public networks, where you pay for bandwidth, right? So, what are the kind of, and then you also have this private network option of build it yourself and using unlicensed spectrum. What are kind of the economic, kind of perceptions or data we can share with some of the team here?
Yeah, I think what we end up finding is that if we've got kind of clusters, campus type rollouts where we want to segment our operational technologies, it's a mixture of, what can we save by not paying those data tolls to the carriers for every SIM card that we activate, making sure that we have the right data plans, avoiding overages, maybe having access to the tooling so we can activate, deactivate on the fly, and comparing that against what that infrastructure looks like. And then also, from a security perspective, it's really hard to put a cost on how much you save by avoiding breaches. And so by segmenting away our operational technologies, we don't have to worry about fish tank thermometers being used as a leverage point into the larger network. We don't have to worry about HVAC systems gaining access to our PCI data systems. It's really that whole segmenting away our operational technologies from our more traditional information technologies and looking at how that works. And I think what we're going to continue to find, and what I've personally been seeing, is that it's not Wi-Fi 6 versus 5G. It's really that the two technologies complement each other very well. They do a lot of the same things, but how they get there, it's an operational decision on what security and benefits you can get. And as always with technology, picking the right technology to solve our service and application needs.
Perfect, great. So let's see if we got any more questions coming in. Yeah. As we were going there, some of the, I was kind of framing up some of the questions, but I don't think we have any more questions really in the chat, but I think hopefully this was helpful. Hey, if you have a few minutes, you just want to, if you'd like to hear a different flavor of this, we're trying to do more conversational topics and be more adaptable in real time to our audiences versus just doing slideware to you. If you like this format, please let us know. If you don't, let us know. And if you'd like to see more of a technical or more of a business, let us know as well. That's what we're here for, is to help you understand and do the right thing and plan and get educated. And we're always here to have fun as well. If you're ever in the Cincinnati, Covington area, please stop by or reach out to Step CG. Be happy to help you and talk to you about anything related to the network. So thanks again.
Thanks, everyone.
Thanks,
You.
Nelson. Thanks, Ben.
Thanks, guys.